Hello, welcome all. Hello, 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 hello. Is the voice clear? Hello. Is the voice clear? Hello. Is the voice clear? सब क्लियर है ना? सब क्लियर है ना? So I am doing new questions, sir. ऐसा नहीं कि I am doing ISRO previous year's questions. No, I am not doing ISRO PYQ. So PYQ already that is your headache. Okay. So this is some. I'm doing some new questions. Wherever you need some theory, I'll give you. Okay, sirs? Chaliye, let us start. The batch is already started, Chandrayaan batch, exclusively for ISRO. Exclusively for ISRO on 4th June. Two subjects are going on. You can join if you wish to do so. Okay? You can join if you wish. ठीक है सर? वॉइस सब क्लियर है ना? लेखराज, चलो, let us start without wasting time. Chandrayaan batch, and we are discussing we are conceptual questions, and we'll cover see key in a given time will be covering complete syllabus. Okay, चलो start करें. चलिए, हाँ आइए, फ्लूइड मैकेनिक्स, एंड उसके बाद क्लास के बाद बता देना कमेंट्स में व्हाट अदर सब्जेक्ट्स डू यू वांट. ओके, चलो लेट्स स्टार्ट. And one request to all of you, please do not use calculators. Please do not use calculators. Let us try to solve together without calculator. There are some numericals also. I have given some numericals, but no need of any calculator. Okay, sir? Chalo, start. देखो, the vertical component of hydrostatic force on a curved surface is equal to. Answer बता दीजिए. These are not PYQ, sir. These are the questions which I am expecting. Answer दीजिए sir. You know, my dear students, if you want the horizontal component on the curved surface, horizontal component will be equal to hydrostatic force on vertical projection area. Hydrostatic force on vertical projection area. Vertical projection area. Is he asking horizontal component of force? No, he is asking vertical component. So vertical component is equal to weight of the liquid. Vertical component on curved surface is weight of the liquid. Contained by the curved surface. Contained by the curved surface. Taken up to free surface. Up to free surface. Let me explain what this is all about. Suppose you have, my dear students, suppose this is the free surface. Now there is a curved surface like this. Suppose this is A and this is B, and this is the curved surface, and of course this is the plane vertical surface. If you want the force on this curved surface, what are we supposed to do? Just take the beginning of the curved surface, end of the curved surface, and this curve up to the free surface, and find the weight of this liquid. That weight of the liquid will give me the hydrostatic force on the vertical component of hydrostatic force. Is it okay, sir? Bolo re. Okay. So what is the answer, sir? What is the answer? Weight of the liquid vertical about it. Is it correct? Yes. Very good, sir. Very good. Very good. Next. Yes. Now, boliye. In a hydrostatic press, इसको थोड़ा हल्का सा कम कर देंगे सर. हाँ. In a in a hydraulic press, this hydraulic press works on which principle? Pascal's law. Whenever a pressure is applied at a point, it is transmitted equally in all directions. That is one statement. Or pressure at a point in a static fluid is equal in all directions. Okay, चलो वो apply करेंगे. So RAM has 12.5. देखो, let me show you like this. ठीक है. Right. The gravitational effects are neglected, and here we have a fluid. Here we have a fluid. ठीक है सर. मैं जहां जहां theory चाहिए, I'll give you. Okay. Now, what is that? RAM has 12.5 meter diameter. So this diameter is 12.5 centimeter diameter. Okay. And plunger, this is the plunger. Plunger has 1.25 centimeter diameter. ठीक है सर. What force would be required on the plunger? He is asking this force, this force, this force. So to raise a mass of 1 ton, what do you mean by 1 ton? 1 ton is 1000 kg. 1 ton is 1000 kg. So we are lifting a weight of 1000 kg. देखिए, 1 ton is 1000 kg, sir. 1 ton is 1000 kg. But I want weight. What is the weight, sir? mg. The mass is 1 ton, that is 1000 kg. So this weight can be written as mg. What is m? 1 ton is 1000 kg into g is 9.81. So that will be equal to 9810 Newton. Exactly. Is it correct, sir? बहुत बढ़िया. देखिए. Now, you know, when the pressure is applied at a point, it is transmitted equally in all directions. Whatever the pressure you are applying, the same pressure should be reflected here. So therefore, F by, what is the area? Pi by 4d square should be equal to this W by pi by 4 capital D square. So pi by 4 is gone. F by small d. What is small d? 1.25 ka square should be equal to capital W. W is 9810 by capital D square. What is capital D square? 12.5 square. You may be wondering, sir, why are you not converting from centimeter square to meter square? The reason being, this is also in square centimeter, this is also in square centimeter. So, and this is in Newton, so this will also be in Newton. Corresponding, ये ratio है, sir. तो कितना आएगा, sir? I think we can write F as 9. No need to use calculator. Please do not use calculator. 1.25 square. तो कितना आएगा सर ये? I think it is correct ना? 110, 100. तो is it 98.1? Is it 98.1? Is it 98.1, sir? If I calculate this, no need to use calculator. 98.1 Newton. देखो, I have selected questions in such a way. Complete fluid mechanics I have selected, including machinery questions, fluid machinery questions. So I am expecting these questions. कोई बात नहीं सर. देखो, हाँ, ये बहुत popular question है सर. I don't know the reason. The general continuity equation is dou rho by dou t plus dou by dou x of rho u plus dou by dou y of rho b plus dou by dou z of rho w, and that is equal to 0. This is the generalized continuity equation. For this, we make only one assumption. What is that assumption, sir? Mass is continuous. There are no gaps, there are no pores, so mass is continuous. That is the equation. So, अब देखो, he is asking this question. Let us assume the fluid to be incompressible. Let us assume fluid to be incompressible. Whenever the flow is incompressible, there is no change of density, so this will be 0. Incompressible density is constant, take it out. So rho dou u by dou x. Incompressible rho is constant, dou v by dou y. Incompressible rho is constant, so dou w by dou z, and that is equal to 0. Rho cannot be 0, so therefore this will be 0. So in order to obtain this equation, I have made only one assumption. What is that assumption, sir? The flow is incompressible irrespective of whether the flow is steady or unsteady. So you can apply this equation whether the flow is steady or unsteady. If the flow is steady, my velocity components do not vary with time, because already time is hidden in velocity, time is hidden in velocity, time is hidden in velocity. So do not get confused. Sir, in this equation there is no time, therefore it is for steady. No. So whether it is steady or unsteady, it will be reflected by these velocities. So therefore, this is valid for any incompressible flow, irrespective of steadiness. Can apply this equation for steady incompressible, or I can apply this equation for unsteady incompressible, but the only condition required is the flow should be incompressible. So kya bola? Ideal flow, gunner. Incompressible whether the flow is steady or unsteady. B is the right option. Is it okay, sir? Boliye babu. Bolo. Hanji sir. Hanji sir. Next. Take this question. Please, it's a request. Don't use calculators. Okay. While water passes through a given pipe, what does given pipe mean? The diameter is fixed. At a mean velocity v, chalo water is flowing. What is the velocity, sir? V. The flow is found to change from laminar to turbulent if another fluid of a specific gravity 0.8. ठीक है sir. What is the density of water, sir? It is 1000. ठीक है. Now another fluid is used. What is the density of another fluid, sir? देखो, it is 0.8. If the specific gravity is 0.8, density will be 0.8 into 1000, that is 800. Some fluid F बोलेंगे इसको, some fluid F. Okay. And the coefficient of viscosity is 20% of that of water. The viscosity of this fluid is 20% of the viscosity of water. Let mu W be the viscosity of water. Okay. So passes through the same pipe means diameter will be same. The transition of flow from laminar to turbulent is expected to occur. It is a pipe flow, sir. It is the fluid is flowing through pipe. So when the fluid is flowing through a pipe, the flow from laminar to turbulent occurs at a Reynolds number of 2000. So therefore, whenever the flow is undergoing transition, what will be fixed? Reynolds number is fixed. So in both pipes, the transition is occurring. Means the flow is changing from laminar to turbulent. So what will be constant? Reynolds number. So you equate Reynolds number in water pipe to that of another fluid. So Reynolds number in water pipe should be equated to Reynolds number in fluid. So what will be this? Rho of water, V velocity of water diameter by mu of water should be equal to rho of fluid. What is Reynolds number? Rho V D by mu. So rho of fluid, velocity of fluid, diameter by mu of fluid. So why are you not writing dWdF? Because it is flowing through a given pipe, same diameter. So this gets cancelled. Okay. What is the density of water? 1000. And the velocity of water here is given as V only. Chalo, koi baat nahi. But the viscosity of water be mu W. And that is equal to what is the density of fluid? 800. And velocity of that fluid is not known. By viscosity of fluid is 0.2 mu W. So this mu W is gone. So you will get velocity of the fluid will be equal to velocity of fluid will be equal to kitna hoga sir? 1000 V into 0.2 into 0.2 1000 V into 0.2 by 800. So what is the value, sir? Anyone? Vf is equal to. So ये कितना आएगा sir? 2 by 10. मतलब I think you are getting V by 4. Am I right, sir? So V by 10 मतलब 8000 आ रहा है. 1 by 4000. So V by 4 is it correct, sir? बहुत बढ़िया सर, बहुत बढ़िया. V by 4 D. ठीक चल रहा है सर, बताइए. So should I increase the pace or this speed is okay? अच्छा क्वेश्चंस लग रहे हैं सर, मतलब इसरो के लेवल के क्वेश्चंस लग रहे हैं सर. बोलो बाबा. एंड वन मोर थिंग, कल से एक बैच शुरू हो रहा है सर अन अकेडमी पे. स्पीड इज ओके ना? चलो नेक्स्ट. हाँ करो सर. बैरोमीटर. Barometer is used for measuring atmospheric pressure. So A is matching to 2. ये गया सर. ठीक है. A is matching to 2. ये गया. Then next. YouTube manometer. थोड़ी देर तक रुको. Hydrometer is used for specific gravity, relative density. Exactly. So therefore, B is matching to 3. B is matching to 3. ठीक है सर. And gauge pressures. Odon's pressure gauge is used for gauge pressure. So 1 is matching to D. कहाँ है रे? D1. So I think what is the option, sir? What is the option, sir? Is it D? Yes. C4. What is C? C क्या है? U-tube manometer. तो pressure differential. Yes. Differential manometer, U-tube manometer. So when you connect like this, yes, it will measure differential pressure. Pressure difference between these 2 points. Is it clear, sir? तो option D is correct. Okay, sir. Okay, sir. एक बार सब लोग बोलो. Okay, sir. Okay, sir. बोलो. नहीं बोलते रे आप. नहीं बोलते. ठीक चल रहा है सर. हाँ. Can you see this, sir? I'll tell you. I'll tell you. यहाँ पे नो 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 नो, इसको कलर चेंज करेंगे सर. पानी को यहाँ लाएंगे. एक सेकंड. दिस इज वाटर. This no need to use calculator. This is water. Clearly गया. Specific gravity is 1. किसका specific gravity 1 है सर? Water. So this is water. Okay. And this is some other fluid. And the specific gravity of this fluid is 0.6. इसका specific gravity 0.65. ठीक है सर. Now there is another fluid. Therefore ये वाला. Okay, क्या पूछ रहा है सर? What is the pressure difference between B and A? Pressure difference B and A in centimeter of water. In centimeter of water means everything I should convert in terms of water. Okay. Now look at this side. This is 50 centimeter. तो क्या करेंगे सर? Let us put everything in. Let the pressure here be PA. Okay. Now from here I move in upward direction. When I move in upward direction, pressure decreases, so minus. So upward minus downward plus. So let the pressure here be PA. This is A. Let the pressure here be PA. So PA लिखा है सर. From here upward minus minus. So this is 50 is in terms of 0.8. The specific gravity of this fluid is 0.8. तो क्या करेंगे सर? H1 S1 is equal to H of water S of water. You convert this 50 centimeter from 0.8 in terms of water. देखो, this 50 is in terms of which fluid, sorry, which fluid is 0.8 should be equal to, I want in terms of water. What is the specific gravity of water? 1. So therefore, this 50 centimeter of this fluid is equal to, ये कितना होगा sir by 10? 40 centimeter. This will be equal to 40 centimeter. So what I am doing is, let the pressure here be PA. I repeat, let the pressure here be PA. Okay. Now यहाँ से upward is minus. So this 50 centimeter from 0.8 is equal to 40 centimeter of water. Answer is also required in centimeter of water. So you are here. यहाँ से आप इधर जाइए ऊपर ऊपर. From here I move upwards. It is minus. ये हाइट कितना है सर? 25. This 25 is in terms of 0.65. तो क्या लिखेंगे? 25 into 0.65 is equal to H of water. Specific rate of water is 1. तो ये कितना रहा है सर? It will be 25 into 0.65. ठीक है सर. यहाँ गए. But this is same as this. यहाँ से jump मारो because same fluid, same height. यहाँ से jump मारो. यहाँ से directly नीचे आ जाना. नीचे कितना? 100 centimeter. Directly it is in terms of water. No need to convert. Directly नीचे आ जाना. नीचे means it is plus. Downwards is plus. How much is that? 100. And that should be equal to, when I reach here, it is PW. And he is asking PB minus PA. तो PB minus PA is equal to minus 40. ये कितना होगा सर? ये कितना होगा रे? By 100. 1 by 4. एक सेकंड. By 100. 1 by 4. 65 by 4 कितना आएगा सर? 65 by 4. Is it correct? What is PB minus PA, sir? 43.75 na? I have not used calculator, sir. गलत हुआ कहीं पे? Is this correct or कोई कैलकुलेशन मिस्टेक तो नहीं किया सर? Means 44. गलत है या सही है? कल का न्यू बैच अन अकेडमी प्लस पे है. So two courses are starting. One is metal forming and fluid mechanics. Okay. Metal forming Deepra sir is taking. Fluid mechanics Negi sir is taking. Okay. कल शुरू हो रहा है. हाँ. ये सही है ना सर? I think 43.75. So 43.75 is correct. Is this correct? Yes. 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 Correct na? Next. A metallic piece weighs 80 Newton in air and 60 Newton in water. The relative density of metallic piece is, okay, my dear students, why do you think there is a weight loss? The weight loss is due to buoyancy. So therefore, now, which one will give you correct weight or correct mass? When you are weighing in air. Why? Because in air, as the density of air is less, buoyancy effects are negligible. So you will get the correct weight of the body when it is weighed in air. So correct weight kitna hai sir? It is weighed in air 80. So can I calculate the correct mass? You know, weight of the body is equal to correct weight is 80. Correct weight is 80. So W is equal to mg. So if you want mass of the body, sir, why are you calculating mass of the body? Because he is asking relative density. Means actually he is asking density. Density is mass by volume. So let me calculate mass. Mass is weight by g. So therefore, mass is equal to weight. What is weight? 80 by g. Excellent, sir. ये हो गया mass. Now, how to calculate volume, sir? देखो, what is the difference in देखो weight loss? Weight loss is equal to 80 minus 16. So in air it is 60, in water it is 40, the difference is 20, that 20 should be equal to buoyancy force. So weight loss is equal to buoyancy force. What is buoyancy force? Rho of the fluid, G into volume of the fluid displaced. Very good. So you are immersing the body completely and checking the weight in water. So when the body is immersed completely, so how much fluid is displaced? It will be equal to volume of the body. So this volume of the fluid displaced can also be written as volume of the fluid displaced can also be written as volume of the body. We can also write this as volume of the body. So therefore, volume of the body is equal to 20 by rho of fluid into G. Volume of the body. Okay. So this will be 20. What is the density of fluid, sir? It is water. So 1000. Fluid is water, so therefore it is 1000. So I know the mass, I know the volume. I can calculate density. What is density? Mass by volume. 80 by G by volume is 20 by 10 power 3 G. So G कट गया सर, ये ऊपर जाएगा 2124. So it will be 4000 is the density. Is he asking density? No, relative density. Relative density is nothing but density by density of water. So density of this object is 4000. Water density is 1000. So the answer is 4. Anyone got the answer, sir? सर यहीं पे इतना अच्छा कर रहा है तो हम हमारे चंद्रयान बैच में कितना अच्छा करेंगे? देखो नीटली. ठीक है सर. तो आंसर इज 4. नेक्स्ट. ये वाला ले लो. अब दिस इज अ गुड क्वेश्चन. टेक दिस क्वेश्चन. Come on, come on, come on. Let's not waste time. Two identical pipes. I tried my level best to include fluid mechanics, all topics. हाँ जी, Sai Nagendra. Yes, yes. Sid Nagendra. Yeah. हाँ. Two identical pipes of length L and diameter D and friction factor F are connected in parallel. देखो. This is one pipe. This is another pipe. They are connected in parallel. ठीक है. What is the length of this pipe? L. What is the diameter of this pipe? D. Okay. And the friction factor is F are connected in parallel at 2 points. For the same total, the word is total. For the same total volume flow rate, if the flow rate is Q, In this pipe, what will be the flow rate, sir? It will be Q by 2 because both are identical. So the discharge will split exactly. So therefore, as these two pipes are of same diameter, same length, identical, the discharge will split exactly half. Okay. Now it is to be replaced with a single pipe. It is to be replaced with a single pipe. I don't know what is the equivalent pipe. I don't know what is the diameter. So let the equivalent diameter be D. And he said, with the pipe diameter, same diameter, here the diameter is D, iska bhi diameter, the equivalent pipe diameter is also given as D. Please listen, it should be replaced with the pipe of same diameter D, same diameter, and same friction factor. Okay. And what is the single length? Ye wala length pucha hai sir. So when can I say, when you are replacing, what should be same? The discharge and head loss will be same. Ab dekho sir, how can I find out head loss? Acha question hai sir. Ye acha question hai sir. This is a very good question. Now, can you tell me what is the head loss in this? In the equivalent pipe, F L Q square. The total discharge is Q here. Why? Because whatever the total discharge it is carrying, here also it should be same. Here only said FLQ square by 12 d power 5. This is the head loss in equivalent pipe. Now, what is the head loss in this pipe, sir? In this pipe, what is the head loss? So, अगर आपको head loss चाहिए, either I can go like this, or देखो the same time आप दो pipes में नहीं जा सकते. So whenever you want to calculate head loss, always it is between sections. Let me repeat. Whenever you want to calculate head loss, it is always between sections. So if you want the head loss between these two sections, this section, either you move like this or you move like this. You cannot move through both pipes at the same time. So इसलिए मैं इसको हटा दूंगा. Either I go like this or like this. ठीक है sir. So ऐसा जा रहा हूं sir. I'll go. So what is the head loss, sir? What is the head loss between these two sections? It will be F L Q square is Q by 2 whole square by 12 d power 5. This is the head loss in this pipe. So when can I say equivalent or replace करेंगे? When the head loss is same. Equate करो sir दोनों को. No. So FLQ square by 2 square is 4. So 12 d power 5 into 4. I repeat, FLQ square by 2 square is 4. 12 d power 5 should be equal to LEQ square by 12 d power 5. So 12 d power 5, 12 d power 5 is gone. FQ square is gone. देखो, FQ square is gone. तो ये L बचा है सर. L by 4 is equal to LE. So the equivalent length is equal to L by 4. दूसरा भी तरीका बताता हूँ सर. When you are replacing a single pipe, तो समझ में आ रहा है नहीं आ रहा सर? Is the question clear, sir? Please tell me, is the question clear, my dear students? If it is not clear, I'll explain again. Clear? See, I have not used calculator anywhere. ये पढ़ो. The velocity potential is given by x square minus y square. What is the magnitude of velocity? You know, u is equal to minus dou phi by dou x. So what is the value of u, sir? Minus. What is dou phi by dou x? It is 2x. ठीक है, sir. And v is equal to minus dou phi by dou y. Okay, sir. So what is this minus? What is dou phi by dou y? Dou phi by dou. When you are differentiating partially, you treat other variable as constant. You are differentiating with y, so it should be treated constant. Dou phi by dou y is equal to minus 2y. So this can be written as minus of minus plus. So the velocity vector is given by this is minus 2x, huh? Minus 2x I cap plus 2y j cap. Excellent, sir. This is the velocity. But he is asking at 1, 1. So velocity is equal to minus 2. X is 1 and y is 1. So therefore, the velocity is given by minus 2 I cap plus 2 j cap. So he is asking the magnitude of velocity. So therefore, it will be under root of minus 2 square plus 2 square. So V is equal to 4 plus 4 is 8. So 4 into 2. So therefore, I think it is 2 root 2 is the right answer. Is C correct? Is C correct? आया ना? Say something, sir. Prepare for ISRO. Okay. I start today. Is it possible to complete before the examination? Horizon. I cannot tell you arbitrarily. Call me after the class on this number. I'll talk to you because I want to discuss certain things before taking any decision. It should not be worst decision. So we have to analyze properly. तो आप क्लास के बाद इस नंबर पे कॉल कर लेना, ठीक है मिस्टर हॉराइजॉन? ठीक है सर? Have you noted my number? If you have noted my number, I'll delete. अरे कौन है रे? पूछा और गया, कुछ रेस्पॉन्स दिए तो भी नहीं है. ओके, जस्ट आई एम डिलीटिंग दिस. हैव यू नोटेड द नंबर? ओके, ठीक है, चलिए. नाउ नेक्स्ट ये करो. आई वांट यू पीपल टू आंसर. कम ऑन प्लीज आंसर. देखो, देखते हैं सर. ये बोल रहा है the relationship between shear stress and velocity for ideal fluid, Newtonian fluid, non-Newtonian fluid respectively का word miss है यहाँ पे. Yes. For ideal fluid, what is the shear stress? 0. Because you represent ideal fluid. If I plot a graph of velocity gradient and shear stress, this is the ideal fluid. And this is Newtonian fluid. This is ideal solid. This is dilatant. This is pseudoplastic. I think you know this. Very good. अब देखते हैं सर. Now for this is wrong. This is wrong because first is ideal fluid. Ideal के लिए tau 0. Next is Newtonian. For Newtonian, what is the flow equation? Tau is equal to mu du by dy. So next is Newtonian. Or यार ideal Newtonian and yes du by dy. Tau is mu du by dy square. It is wrong. So tau is yes. This is correct. And non-Newtonian is this. एक बार देखना. Tau is equal to a du by dy whole power n plus b. And if it is a classical fluid, b will be 0 and tau will be equal to a du by dy का whole power n. So if n is greater than 1, what is that fluid, sir? अब मुझे बताओ सर, ये कौन सा non-Newtonian fluid है? Which non-Newtonian fluid is this? Can anyone tell? There are different fluids like pseudoplastic, thixotropic, dilatant fluid. Which one is this, sir? ये स्क्वायर है यहाँ पे. हाँ. It is dilatant, sir. Tau is equal to a du by dy whole power n. If n is greater than 1, it is dilated. तो ये dilated है. Of course non-Newtonian है. इसमें नहीं पूछा लेकिन फिर भी I am giving. Is it okay, sir? Yes, it is shear thickening. Absolutely correct. Shall we proceed? Yes, it is shear. Great. Shear thickening. Take this. In an impulse turbine, the maximum hydraulic efficiency is given by wait. 1 plus k cos phi by 2. ये मैं पेल्टन व्हील में डिराइव किया था सर. This I have derived in पेल्टन व्हील. Okay. So if k is 1, blade friction coefficient. Generally, because of friction, the exit relative velocity will be less than inlet relative velocity. तो अगर frictionless blades है तो we take kr. This is the equation. If k is 1, मतलब vr1 is equal to vr2. जब k 1 होता है, friction नहीं होता है, then the maximum efficiency will be equal to. ये याद रख लेना सर. क्या पता कल अगर यही क्वेश्चन आए तो मैं कुछ बातें बताने वाला हूं सर. Wait. Is the option C correct? Yeah. 1 plus, yes, correct. This can also be asked like if the blade friction coefficient is given. ये होगा सर. तो आप लोग एक बात बता सकते हैं सर, बीईएल में अलग सा पेपर आया था. तो यू हैव कवर्ड सम 3 to 4 सेशंस. बट हार्डली फ्यू क्वेश्चंस हैव कम, आई नो दैट। आए तो आए, लेकिन कम आए, मुझे पता है सर कहां से आए, मैं बताऊंगा। व्हेन आई कवर 4 to 5 क्वेश्चंस हैव कम, लेकिन मैं आई वाज एक्सपेक्टिंग अराउंड 8 to 10। तो ऐसे पीएसयू के क्वेश्चंस कुछ अलग होते हैं सर, वी कैन नॉट प्रिडिक्ट, बट इसरो बार एक स्टैंडर्ड होता है सर। सो देयरफॉर यू विल बी सीइंग लाइक इससे आप डेफिनेटली एडवांटेज होगा सर। इट्स माय फर्म बिलीफ। ओके, ठीक है सर। क्लास के बाद कमेंट, जब वीडियो एंड होता है, कमेंट में शेयर करना कि आपको क्या क्या सब्जेक्ट्स चाहिए, मुझे बता देना, सो दैट आई प्लान अकॉर्डिंगली। चलो, हाँ ये बोलो। The flow separation is likely to take place. किस प्रेशर ग्रेडियंट में फ्लो सेपरेशन होता है? पॉजिटिव प्रेशर ग्रेडियंट्स। So positive pressure gradients are known as adverse pressure gradients. So boundary layer separation occurs under positive pressure gradients. And these positive pressure gradients are also known as adverse. Adverse का मतलब bad. So separation is not taking place in negative pressure gradients. They are also known as favorable pressure gradients. So what is the answer, sir? What is the answer? The flow separation is likely to take place when the in the direction when the flow is adverse. Is it okay, sir? बोलो सर। ठीक है। Shall I continue or stop? आप बताइए, बंद कर दूं? मेरी मर्जी, अब आप बताओ सर। You may be wondering, ऐसे कुछ बड़े क्वेश्चंस आएंगे ना? If you see ISRO paper, there are some questions where figures are also given, and इसके लिए कैलकुलेटर की जरूरी भी नहीं है सर। Read the question. Read the question. A float valve of ball cock. This the ball. This the ball. यहाँ पे बंद कर रहे हैं, देखो हम बंद कर रहे हैं ये बॉल से। Is required to close an opening of a supply pipeline. This is the supply pipeline. ये pipeline, and we have to close this, my dear students. We have to close this. इसको close करना है, ठीक है? By receiving a system as shown in the figure. So we have to close this wall with the help of क्या है? This wall cock. The buoyant force required to be exerted by the fluid to keep the wall closed against the pressure of 0.2. यहाँ पे मेरे प्यारे दोस्तों मैं समझाता हूँ सर। I'll make you understand. There is a buoyancy force here. देखो ये पूरा फ्लूइड है, इस फ्लूइड पे this is all fluid sir, this all fluid, इस फ्लूइड पे the buoyancy force is acting, ठीक है सर, there is a buoyancy force. And you also know very well, my dear students, you also know कि यहां का प्रेशर दिया है सर। हियर द प्रेशर इज गिवन, हाउ मच इज द प्रेशर गिवन? 0.28 mm स्क्वायर। देखो तो ये प्रेशर ऐसा है सर, देखो दिस फ्लूइड पाइप में प्रेशर ऐसा एग्जर्ट हो रहा है, ठीक है सर। माय डियर स्टूडेंट्स, कैन आई कैलकुलेट दिस फोर्स? यस सर। फोर्स इज इक्वल टू प्रेशर इनटू एरिया, ठीक है सर। फोर्स इज प्रेशर इनटू एरिया। The pressure is 28 Newton per mm square, and the area is 5 by 4 d square. What is the diameter of this 10 mm square? Already this is in mm. Do not change it. So therefore it will be mm square. So mm square is gone. Wait for a while. So F is equal to what will be this? 28 by 4. Calculator मत use करना. 28 by 4 into 100. Into 100, 28 by 4 into 10 square is 100. Pi is 22 by 7. जादू देखो यहाँ पे, खटाखट कैंसल हो जाएगा, खटाखट कैंसल हो जाएगा। F will be equal to 2200 न्यूटन। ये मत सोचना कि सर ने न्यूमेरिकल्स दिया, इसरो में तो न्यूमेरिकल बेस नहीं आएगा, आएगा सर। समझ गए? डिजाइन ऑफ क्वेश्चन देखो आप। So therefore यहाँ पे फोर्स एक्ट हो रहा है। दिस फोर्स इज, हाउ मच इज दिस फोर्स सर? इट इज 2200 न्यूटन, एंड यहाँ पे मूवमेंट ले लेना बिकॉज यहाँ पे टिल्ट हो रहा है। तो दिस इंटू 2200 इंटू 100 this is clockwise, should be equal to Fy into 500. Fy into 500. F कितना है? Buoyancy force into 500. खत्म सर. Therefore, if you want the buoyancy force, तो ये सही है या गलत है? सही. Yes, yes, this is gone. तो 2200 by कहीं पे मिस्टेक किए सर हम? कहीं पे तो मिस्टेक किए क्या रे? 22 न्यूटन. कहाँ 22 न्यूटन आ रहा है? कहीं पे तो मिस्टेक किए क्या? ओ हो प्रेशर इज 0.28. खरमा रा बाबू खरमा. प्रेशर इज 0.28. 0.28 गया. खत्म. बाय बाय टाटा गुड बाय गया. Pressure is 0.28. 0.28 means it is 22 Newton. So it is 22 Newton. 22 Newton. So it will be FB will be equal to 22 by 5. No calculator please. 5 4 20 point again 4 4.4 Newton. अच्छा क्वेश्चन था सर. अच्छा क्वेश्चन था या नहीं? सिंपल सा टेक्नोलॉजी हमारे बड़े साहब बोलते हैं. अब बड़े साहब कौन है आपको पता कर नहीं लेना है. दुकान बंद करो या चलाओ? Shall we continue? Because I am not getting any comments from your side. ये करो. हाँ. Using Prandtl's mixing length concept, how is the turbulent shear stress related? The turbulent shear stress is given by rho u dash v dash, where u dash and v dash are fluctuating components in x and y directions respectively. So as per Prandtl's mixing length theory, u dash v dash is equal to L du by dy. What is L? Prandtl's mixing length. What is the concept of Prandtl's mixing length? It is similar to your mean free path of gases. Okay, which I explained very clearly in flow. So shear stress in turbulent flow is given by rho. What is u dash? L du by dy. Okay. And what is v dash? V dash L du by dy. So therefore, the turbulent shear stress is given by प्यारे दोस्तों rho L square du by dy का whole square. So therefore, what is the answer, sir? I think D is the right answer. बहुत बढ़िया सर. Next. ये करो. Come on, let's not waste time. Let's not waste time. आए तो बेस्ट देके जाओ सर. You know, the capillary rise is given by 4 sigma cos theta by WD. How is capillary rise and diameter related? In fact, they are inversely related. ठीक है सर. If the diameter is doubled, look at. If the diameter is doubled, if you are increasing, this will decrease. If it is doubled, it becomes half. So what is the answer, sir? So H2 by H1 is equal to ulta T1 by T2. So what is the capillarized Bujana? So H2 by H1. What is D1? What is T2, sir? D2 कितना है सर? D2 is twice D1. तो ये कर गया. तो H2 is equal to H1 by 2. It becomes half. Is it okay, sir जी? हाँ जी सर. देखो एक सेकंड देखो सर. ऐसे क्वेश्चन आ रहे हैं. जस्ट देखो एक बार. फ्लूइड प्रॉपर्टीज आया. कैसा प्रॉपर्टीज आया सर? कैसा आया? न्यूटोनियन नॉन न्यूटोनियन का. उसके बाद बुयांसी आया. उसके बाद हाइड्रोस्टैटिक फोर्सेस देखे. उसके बाद ये देखा क्योंकि हाइड्रोस्टैटिक फोर्स में क्या था? वर्टिकल वेट ऑफ द फ्लूइड इज लाइक वर्टिकल कंपोनेंट वेट ऑफ द फ्लूइड. उसके बाद प्रेशर मेजरमेंट आया. उसके बाद पाइप नेटवर्क आया. मींस ऑल एरियाज आर इक्वली गिवन इंपॉर्टेंस इन दिस क्लास सर. खुशियां नहीं बंदा खुशो की नहीं. हाँ बोलो. चीज चिप्स खा रहे थे आप? चीज वाले चिप्स खाते क्या? हाँ चलो नेक्स्ट. टेक दिस. देखो बहुत अच्छा क्वेश्चन है सर. A stepped pipeline with four different cross sections. This is the meaning of stepped pipeline. Something like this. Means pipes in series. ठीक है sir. हाँ. Given. Match areas. Areas are given 500, 100, 400, 200. Yeah. This area is 500. This area is 100. This area is 400 and this area is 200 and the fluid is flowing. What will remain constant, sir? इसमें क्या constant रहेगा? Whenever pipes are in series, stepped pipeline, what will remain constant? This charge. So look at it. He says, what? How much fluid is flowing, sir? 2 liters per second. 2 liters per second. ध्यान से सुनो. हाँ. What do you mean by liter, sir? You know, क्या करेंगे सर? 1 liter is equal to 1,000 cubic centimeter. Correct or not, sir? 1 liter is 1,000. तो 2 liter का मतलब what is the discharge, sir? It is 2 liter mean 2,000 centimeter cube per second. Absolutely fine. Very good, sir. And the areas are also given in square centimeter. This is square centimeter. This is square centimeter. This is square centimeter. This is also square centimeter. Now, everywhere discharge should be constant. तो अगर आप multiply करेंगे तो देखो discharge is equal to area into velocity. जब आप ये दोनों multiply करेंगे, you should get 2,000. When you multiply these two, you should get 5,000. This 2,000. किससे मल्टीप्लाई करेंगे तो आपको 2000 आएगा. 500 into what is equal to 2000? 4. So therefore it is 4. Correct. 100 into what multiplied you get 2000? It is this. 400 into what is multiplied that you get 2000? It is 5. 200 into what multiplied you get this? It is 10. So A is matching to 1. So ये खत्म. Bye bye. Tata goodbye. And B is matching to 5. Ho ho ho. C is matching to 2. खत्म. Bye bye. Tata. So B is the right answer. अच्छा क्वेश्चन था या नहीं? बोलो रे. इसरो के लायक है या नहीं है? बोलो. आप कुछ नहीं बोलेंगे रे. Say something रे. Shall I continue or दुकान बंद करूं? Take this. If you want me to continue, I'll continue. Otherwise, दुकान बंद कर देंगे. See, I'm closing. I'm fed up. I'm closing. Bye bye. आपको अच्छा नहीं लग रहा सर? Fluid flow rate Q can be measured with the help of a Venturi tube or Venturimeter with the differential pressures delta P. Measured at upstream point and the smallest cross section that is through it. If the relation is this, what is the value of N? Answer bolo sir. You know, my dear students, discharge is given by CD को छोड़ दो. A1, A2 by root of A1 square minus A2 square. This is the equation. Correct, hai, sir. Can I say the discharge is directly proportional to square root of H? Yes, sir. Because we are not changing A1, A2, G is also constant. Okay. Can you tell me what is H, sir? Anyone? H is actually representing pressure head. Pressure head. So therefore, this I can write. This head is proportional to pressure delta P because this is representing pressure head. The head is H is representing pressure head. So square on both sides. So Q square is proportional to delta P or delta P is proportional to Q square. So therefore, N का value कितना होगा sir? N is equal to 2. N is equal to 2. N is equal to 2. Is it correct? Wonderful question. खुशियानी बंदा खुशो की नहीं. आंसर करो ये. These chips Achal Yadav is correct. Akhil Vaibhav is correct. Siddh, वाह बहुत अच्छे स्टूडेंट्स हैं सर. Whenever the velocity distribution, देखो, when the velocity distribution is uniform, means no changes. Whenever the velocity distribution is uniform, तो क्या होगा सर? When it is uniform, मैं average, suppose you get 60 marks, 60 marks, 60 marks, 60 marks, 60 marks in all subjects. What is the average and actual? Same. So what correction factor is required? No correction. No correction is 0 1 1. अरे यार, you get 60 marks. How can I write k into 60? तो क्या है? Directly देखो, you already you got 60 marks. So what should be this correction factor? Actual and same 1. So whenever the velocity distribution is uniform, no correction factor is required. और एक बार, what is the kinetic energy correction factor for laminar flow? What is the kinetic energy correction factor for laminar flow? Anyone? क्या हो रहा रे? मैं मोमेंटम करेक्शन फैक्टर, आई हैव नॉट आस्क्ड मोमेंटम करेक्शन फैक्टर. क्या हो रहा सर? आप मतलब क्या पढ़ रहे हैं सर? गलत सर. व्हाट इज द काइनेटिक एनर्जी करेक्शन फैक्टर फॉर लैमिनार फ्लो? आपका प्रिपरेशन ही सही नहीं है सर. द काइनेटिक एनर्जी करेक्शन फैक्टर फॉर लैमिनार फ्लो इज 2. द मोमेंटम करेक्शन फैक्टर फॉर लैमिनार फ्लो इज 4/3, दैट इज 1.33. क्या हो रहा सर? वेरी सैड, वेरी सैड, वेरी सैड सर. नॉट हैप्पी. हाँ, ये करो फटाफट फटाफट. Which of the following statement is correct? Minor losses through walls, fittings, bends, contractions are commonly modeled as proportional to anyone. देखो सर, the bend losses are given by, कुछ आइडिया है सर? kv square by 2g. ठीक है. And the sudden contraction 0.5 v square by 2g. तो क्या होगा सर? ये सब किसके फॉर्म में देंगे सर? v square by 2g. It is in terms of velocity head. Everything is expressed in terms of velocity head. Okay sir? Okay sir. बहुत बढ़िया स्टूडेंट्स ऑफ इंडिया. ये करो. वाह वाह वाह. हाइड्रोलिक मशीनरी भी आ गया सर. मजा आ गया सर. सी एंड डी आर सेम. कहां पे सर? Sir, static head, how can it be equal to? Static head is P by W, sir. Static pressure head. क्या बात करते सर आप? कहां पे सी एंड डी सेम बोल रहे हैं सर आप? इसमें तो अलग है. देखो, Francis turbine is a anyone high head low discharge turbine. कैसे सर? Power is equal to WQH. For a given power, if the head, देखो, for a given power, I am talking for a given power, W is very constant. तो QH, देखो, QH is equal to P by W. For a given power and W is anyway specified is constant, QH is constant. If the head is high, discharge will be low. अगर हेड कम है तो डिस्चार्ज ज्यादा होगा. जब डिस्चार्ज कम है तो हेड ज्यादा होगा. वाइस वर्सा. ठीक है. तो पेल्टन व्हील इज अ हाई हेड टर्बाइन. व्हाट इज द हेड ऑफ द पेल्टन व्हील? आई थिंक इट इज मोर देन 200 ना. सॉरी, मोर देन 300 ना. हाँ, अच्छा, डायनेमिक हेड बोल रहे हैं. हाँ, राइट, यू आर राइट सर. या प्लीज, वहां पे मैं ऐसा करता हूँ सर. इसको चेंज करता हूँ. एक सेकंड. इसको मैं ऐसे करूंगा. करेक्ट, आप सही बोले. ठीक है, आप बताओ. ओके सर. अच्छा, मैं यू सेड बी बोला ना. हाँ, ये बिल्कुल सही है सर. यू आर राइट. ठीक है सर जी. हाँ, ये बोलो. अब ओके, इज इट ओके सर? So Pelton wheel is a high head low discharge. Can I say A is matching to 1? Francis is middle sir always. Medium head, medium discharge. So B is matching to 3. हमेशा याद रखना, Pelton, Francis, Kaplan. Francis will be in between. Kaplan इधर तो आएगा या इधर तो आएगा. क्या Francis is always in between. Something like ऑटो साइकिल, डीजल साइकिल, ड्यूअल साइकिल. ऑटो डीजल एक्सट्रीमिटीज ड्यूअल बीच में आएगा. Something like that. हाँ. And Kaplan turbine is a anyone? Kaplan turbine is a low head high discharge. अगर वो low head high discharge तो 4 I think. So is it correct? तो 22nd का बी ऑप्शन करेक्ट है सर. बोलो सर जी. हाँ जी सर, हाँ जी सर. ये करो. Time period of oscillation is given by 2 pi root of kg square by ये होगा. ठीक है सर. So if the metacentric height is more, stability will be more. If the metacentric height is more, it will be more stable. Comes to equilibrium faster. But at the same time, if the metacentric height is more, time period of oscillation will be less. When the time period of oscillation is less, the number of oscillations are more. When the number of oscillations are more, passengers are not comfortable. I explained very clearly in buoyancy. So what is the answer, sir? It improves stability. देखो stability तो ज्यादा होगा. What is the stability तो बढ़ेगा सर. Stability को खराब नहीं करेगा. Stability तो improves stability. Stability तो ज्यादा होगा. Means the period of oscillation shorter. Is it okay? Is it okay? Very good. Next. ये करो. हाँ. Modeling of ship. देखो डायमेंशनल एनालिसिस है. शिप मॉडलिंग कौन सा लॉ यूज करेंगे? फ्राउड मॉडल लॉ. व्हाट इज दैट? v स्क्वायर बाय gl इन मॉडल शुड बी इक्वल टू v स्क्वायर बाय gl इन प्रोटोटाइप. किसी को याद है सर? एंड g तो कट गया. तो vm स्क्वायर बाय lm इज इक्वल टू vp स्क्वायर बाय lp. ठीक है. A 1 meter long model is stored at a speed of 81. तो मॉडल का स्पीड है 81 and what is the length of the model? It is 1. देखो अगर ये मीटर में है, keep it in मीटर सेंटीमीटर पर सेकंड, सेंटीमीटर पर सेकंड. So what is the speed of देखो what is the to what speed of the ship? 64 meter long. So this is given as 64 and he is asking this. Okay, very good sir. Take the root. क्या होगा सर? अगर रूट ले लेंगे तो क्या होगा? 81 into 8 होगा सर. ये 81. तो दिस इज माय बीपी. वेरी गुड. तो कितना आएगा? अरे रूट ले लो, रूट ले लो. 81 स्क्वायर रूट इज 81. रूट 64 is 8. तो दिस विल बी 648. But it will be in centimeter per second. Is it correct, sir? It should be in centimeter per second. Why? Why centimeter per second, sir? Why centimeter per second, sir? Because already this is given in 81. जब 81 is in centimeter per second, this will also be in centimeter per second. But answer is asked in meter per second. So what is the answer, sir? 6.48 meter per second. Is it correct? किसी को आया सर ये आंसर? हे भगवान, क्या हो रहा है मेरे बच्चों को? Is this clear or do you want me to explain again? Oh, 24 questions, 1 hour. अच्छा चल रहा है सर. ठीक है, अच्छा स्पीड चल रहा है सर. The speed is good. The realization of velocity potential functions. You know that velocity potential function exists only for which type of flow? Answer be just. Please give the answer. I want everyone to give answer. I want everyone to. Velocity potential function exists only for irrotational flows, but stream function can exist for rotational as well as irrotational. If the velocity potential function satisfies Laplace equation, I repeat, if the velocity potential function satisfies Laplace equation, automatically it satisfies the continuity equation, incompressible continuity equation. So flow is possible. Similarly, if the stream function satisfies Laplace equation, the flow will be irrotational. If string function does not satisfy Laplace, it is rotational. देखो, the realization, मतलब existence of velocity potential indicates the flow is irrotational. Irrotational. जब भी velocity potential function exist हो रहा है, इसका मतलब it is for irrotational. बहुत बढ़िया सर. ओके सर. हाँ, ये वाला लीजिए. ओ हो ऑप्शंस मिस हो गया सर. ऑप्शंस मिस हो गए. सो शैल आई शेयर ऑप्शंस? मैं ऑप्शन शेयर करूंगा सर. ओ माय गॉड, बाउंड्री लेयर आ गया देखो. एक सेकंड देखो. मैं बताता हूँ व्हाट आर द ऑप्शंस. मैं ऑप्शंस बताऊंगा सर. आई शो यू ऑप्शंस. मैं ऑप्शंस दिखाऊंगा रे. ऑप्शंस आर, देखो सर. ए आर ई पावर -1, आर ई पावर -3, आर ई पावर -2. आंसर बताओ सर. देखो, यू नो, क्या बोला है? The laminar flow. Okay, in a two-dimensional incompressible laminar flow. मैं इक्वेशन देता हूँ. Delta by x is equal to Blasson's equation लेते हैं. It is something like 5 by root REX. इस चेंज, अगर वेलोसिटी प्रोफाइल चेंज हो रहा है तो ये चेंज होते जाएगा. ठीक है सर. तो कैन आई राइट लाइक दिस? डेल्टा बाई एक्स, ये तो लैमिनर के लिए 1 बाई आर ई एक्स की पावर 1/2. क्या हम लिख सकते हैं सर? Delta by x is proportional to, yes sir. So delta by x is proportional to re x की पावर -1/2. हाँ जी सर. एक सेकंड एक सेकंड. गलत है क्या सर? एक बार मैं देख लेता हूँ. लेट मी चेक. एक बार ऑप्शंस देख लेता हूँ सर. लेट मी चेक ऑप्शंस. एक बार ऑप्शंस चेक कर ले रहा हूँ सर. हाँ, बिल्कुल सही है सर. बिल्कुल सही है. -1. यस, बिल्कुल सही है सर. नाउ गिव मी आंसर सर. गिव मी आंसर सर. नो वन इज गिविंग आंसर सर. ये मुझे बुरा लग रहा है सर. So can I write this as -12? Yes, I think C option is the right one. Okay, sir? बहुत अच्छा सर. चलो next. Come on, come on, come on. ये वाला दीजिए सर. Give this. For a flowing fluid, a dimensionless combination of velocity, length scale, and acceleration due to gravity. Anyone? Proud number. V square by GL or V by root GL. देखो, देखो एक बार. ये डायमेंशनलेस चाहिए. वेरी सिंपल सर. अगर आपको कोई डाउट है तो ग्रुप का देख लेना. वेलोसिटी इज मीटर पर सेकंड, तो स्क्वायर क्या होगा? मीटर स्क्वायर पर सेकंड स्क्वायर होगा. जी इज मीटर पर सेकंड स्क्वायर, लेंथ इज मीटर, तो मीटर स्क्वायर पर सेकंड स्क्वायर, तो ये होगा आपका डायमेंशनलेस होगा. सो दिस इज करेक्ट. इज इट ओके? बोलो सर जी. हाँ, ये करो. Anyone with 28? खुशियां नी बंदा खुशो की नहीं. Answer, answer, answer. 28th answer. Inertia to viscous, Reynolds. Inertia to pressure, root inertia to pressure, Euler number. Inertia to gravity, Froude number. Inertia to surface tension, Weber number. Inertia to elastic, root, Mach number. So what is the answer, sir? It is B, Bombay. Bombay is correct. No one is giving. मैं दुकान बंद कर रहा हूं सर. सर डराओ मत. हाँ आंसर दीजिए. इसका आंसर दो. For applying Bernoulli's equation, flow should be frictionless, that is non-viscous. Correct. Flow should be incompressible. Correct. Flow should be steady. Correct. Flow should be rotational. ना. Rotational में क्या होता है? Viscous effects रहेंगे. So this is गलत. A, B, C, 4 is the right answer. Is it okay, sir? A, B, C is the right answer. Okay. ये देखो. ये मैक्सिमम पूछा जा सकता सर दिस क्वेश्चन. मैक्सिमम आस्क. Select the correct options for streamlines, streak lines, path lines for steady flow. And steady flow के लिए streamlines, streak lines, path lines all are identical. For steady flow all are identical. मैं कितना अच्छा beautifully illustrate करके क्लास में बताया था. Wind blowing from north to south, west to east, 11 to 12 ऐसा कुछ बताया था क्लास में. True. ये करो सर. Come on. अच्छा चल रहा है सर. 30 questions. अच्छा लगा मुझे. We have not wasted time. Consider velocity vector V. X, Y, Z are coordinates. Pick one or more correct statement. Actually, आपको इसरो में तो एक ही ऑप्शन सेलेक्ट करना पड़ता, लेकिन मैं नॉलेज के लिए यहाँ पे दे रहा हूँ सर. ओके. Velocity is given as this. What is the Z component of velocity? You know very well. मैं आपको बताया था. ओमेगा Z का क्या था सर? डो V by डो X minus dou u by dou y. याद है सर? This is omega z. And what is divergence? Del dot v. ये क्या है सर? Dou u by dou x plus dou v by dou y. क्योंकि z नहीं है, 2 डायमेंशनल है, z नहीं है, तो dou u by dou x plus dou v by dou y ये सही है सर. Divergence of v. Dou u by dou x plus dou v by and dou v by dou x minus dou v by dou y. ये a c दो सही है सर. a c दो सही है सर. Anyone got only सिद्ध क्या नाम रे? Only Sid Naguria Daguriya. Correct? Correct? सही है या गलत है रे? डाइवर्जेंस अभी क्या था? डो by dou x plus dou v by dou y plus dou w by dou z. करेक्ट और नॉट? मुश्किल है सर आपको पढ़ाना. नेक्स्ट. Some of the components of forces due to pressure and shear at the solid fluid interface normal to the direction of flow ऐसा है. तो ड्रैग ऐसा आता है फ्लो डायरेक्शन में, और परपेंडिकुलर डायरेक्शन में क्या आता है सर, इसके लिफ्ट बोलते हैं सर, इसको क्या बोलते हैं सर, क्या बोलते हैं सर। अरे यार मुश्किल है रे बाबा, मुश्किल है रे बाबा। वो परपेंडिकुलर बोला रे, परपेंडिकुलर डायरेक्शन में बोला रे, फ्लो डायरेक्शन में नहीं बोला रे, वो फ्लो में नहीं बोला रे। अरे he has not asked in flow direction, so in a direction normal to the flow, फ्लो के नॉर्मल में पूछा है, तो लिफ्ट क्लियर। ए भगवान, हाँ यहाँ पे क्यू यूज कर ऐसा कर दिया ऑप्शन देख सके। क्वेश्चन को whenever you get dimensional analysis के questions, डरना नहीं सब, मैं बताता हूँ क्या करना है। The drag force Ft is a function of viscosity mu, density rho, velocity v, diameter d। ओके इतना ही ना, ओके विस्कोसिटी म्यू, डेंसिटी रो, वेलोसिटी v एंड डायमीटर d। ठीक है, क्या होगा सर, लेट अस अप्लाई बकिंगham's थ्योरम। मैं बताया था सर, आई टेल यू हाउ टू डू इट। रिपीटेड वेरिएबल्स ले लेंगे सर, फंडामेंटल क्या होगा, डेंसिटी को तो लेना ही है, और वेलोसिटी, डेंसिटी को मास के लिए लेना है, डायमीटर को लेंथ के लिए लेना है, वेलोसिटी को सेकंड के लिए लेना है। सो दीज आर द रिपीटेड वेरिएबल्स। अब होगा क्या सर, अब मैं बताता हूं। सो पाई 1 इज इक्वल टू डायमेंशनलेस टर्म पाई 1 इज इक्वल टू एफ डी इनटू, देखो these three I am taking as repeated variables. I gave you the reasons why to take these as repeated variables. Rho power a, v power b, e power c. Okay. पाई वन फर्स्ट पाई टर्म, सेकंड पाई टर्म क्या होगा, म्यू के टर्म है, लेकिन वो एफ के टर्म्स भी पूछा है, तो ये लिखेंगे व्हाट इज द डायमेंशनल फार्मूला ऑफ पाई वन, m0 l0 t0। ठीक है सर, फोर्स का ml t पावर -2, करेक्ट, डेंसिटी मास बाय वॉल्यूम ml -3, ma l पावर -3a। ठीक है सर, एंड वेलोसिटी l t पावर -1, डायमीटर LC। क्या ये सही है सर, इज इट करेक्ट और रॉन्ग सर जी, इज इट करेक्ट, आई थिंक इट इज करेक्ट। एक बार देखो फोर्स, दिस इज डायमेंशनलेस 0, mlt -2 फोर्स, रो इज ml -3, यस, वेलोसिटी इज lt -1, तो ओके ओके राइट। तो m का पावर देखो 0 इज इक्वल टू m का पावर 1 प्लस a, 1 m ये हो गया, m ये हो गया 1 प्लस a, तो a इज इक्वल टू -1, l का पावर 0, l यहाँ पे 1 है, तो 1 -3a प्लस b। ठीक है सर, l एक बार देखेंगे, l 1 -3a प्लस b, एंड t का पावर 0, तो क्या होगा सर, t का पावर 0 मीन्स -2 b। एक्सलेंट, तो b इज इक्वल टू -2 आया सर। ठीक है, तो यहां पुट करना 1 -3a, सॉरी 1 -3 टाइम्स a क्या होगा -1, प्लस b इज 2, तो दिस शुड बी इक्वल टू 0। अरे क्या कर रहा हूं सर, मैं क्या कर रहा हूं, मुझे c चाहिए ना, अरे मैं भी पागल हो गया सर। a इज ऑलरेडी नोन, b t पावर 0 -2, नहीं मैं दोबारा बनाता हूं, मैं कहीं भी कैलकुलेशन मिस्टेक किया, आई डू इट अगेन। आई एम यूजिंग बकिंघम पाई थ्योरम। देखो देखो, नो वरीज, देखो नो वरीज। पाई 1 इज इक्वल टू, बिकॉज ही इज आस्किंग इन टर्म्स एफ डी, तो आपको पता है सर व्हाई वी टेक डायमेंशनल क्या बोलते हैं रिपीटेड वेरिएबल्स, हाउ वी टेक, आई हैड एक्सप्लेन्ड इन वेरी मच इन क्लास। तो डायरेक्टली आई एम टेलिंग यू कि रो को ले लेंगे, एंड वेलोसिटी को ले लेंगे, और डायमीटर को ले लेंगे सर। ठीक है सर, तो पाई 1 इज m0 l0 t0 ft। f क्या है सर, m l t minus 2 density m l minus excellent sir and velocity l t minus 1 मीटर पर सेकेंड डायमीटर एल सी करेक्ट सर अब देखो m का पावर देखो m का पावर 1 प्लस a m का पावर 1 प्लस a करेक्ट तो a is minus 1 L का पावर 0 है L पावर 0 means 1 minus 3a plus b plus c am I right sir L का पावर 0 तो L का पावर 0 is L is 1 minus 3a plus b plus c ठीक है and t 0 0 का मतलब t का मतलब क्या है -2 minus b so what is the value of b sir is t -2 sir b is -2 yes यहां पुट करना तो 1 minus 3 a is -1 1 minus 3 a is -1 plus b is -2 b is -2 plus c this should be 0 I have substituted in this तो कितना आ रहा है सर 1 plus 3 minus 2 plus c is 0 तो c का वैल्यू कितना आ रहा है सर 1 minus 2 is it correct sir yes so therefore pi 1 is equal to ft into rho power a what is a sir what is a कितना है a -1 v power b -2 e power c is -2 can I write pi 1 as fd by ये पूरा नीचे ले लो rho v square b square excellent sir so the dimensionless non-dimensional number is this अच्छा लगा सर ये got it or not sir don't think that इतना बड़ा है इसमें कुछ नहीं हम कैलकुलेशन मिस्टेक किए थे is it okay yes exactly ये करो आप लोग इंटरेस्ट शो नहीं कर रहे सर अभी मैं स्टॉप करूं वी हैव डन 34 क्वेश्चंस है हमने 34 क्वेश्चंस किया ठीक है शैल आई स्टॉप फिर आऊंगा तो कमेंट में लिखना प्लीज राइट इन कमेंट्स क्या सब्जेक्ट्स चाहिए और ये कंप्लीट करूंगा सर नेक्स्ट टाइम आई विल कंप्लीट दिस तो आप कमेंट में लिखना ये क्लास कैसा लगा और क्या क्या चाहिए इज इट ओके बोलो सर जी कंटिन्यू करें या बंद करें डू यू वांट मी टू कंटिन्यू और स्टॉप अभी कितने क्वेश्चंस किए सर हाउ मेनी क्वेश्चंस डिड वी कंप्लीट 33 कंटिन्यू करें लेकिन आप इंटरेस्ट शो नहीं कर रहे थे इसलिए मजा नहीं आ रहा फिर से कंटिन्यू करता हूं सर अभी मैं स्टॉप करता हूं लेकिन आपके कमेंट्स आई विल सी सीरियसली इफ यू रियली वांट आप अपने कमेंट में लिखो कि क्या क्या चाहिए क्लास कैसा लगा और क्या क्या चाहिए इन जस्ट 45 सॉरी 70 मिनट्स वी कवर्ड 31 और 32 क्वेश्चंस मतलब 2 मिनट में कोई टाइम वेस्ट नहीं किया सर so if you feel the class is good I made very good questions on SOM, MD, heat transfer, applied thermodynamics, then TOM. Seriously, mechanics तो जबरदस्त बनाया सर. It all depends on you. Otherwise पूरा चंद्रायन में ही पढ़ाऊंगा मैं. मुझे कोई चंद्रायन में पढ़ाऊंगा मैं. कोई बात नहीं. Okay? चलो आज के लिए बस इतना. So I am stopping sir. I am ending. आप कमेंट के फॉर्म में लीव करेंगे तो ही मैं नेक्स्ट शेड्यूल करूंगा. नहीं तो नहीं करूंगा. ठीक है चलो बाय बाय थैंक यू कैसा लगा और क्या क्या चाहिए व्हाट डू यू वांट ओके चलो बाय बाय बाय